Hi everyone. Today we're going to be seeing how to implement the stain design pattern in order to refactor our code to make it more extensible and simpler to read. Now, for this particular example, I've really simplified the logic for this, but let's say that our requirements say that we need to calculate the price of a customer monthly subscription based on their membership type. So if we scroll all the way to the bottom, we're gonna see that here we have an enum class that just has three different states. So one for the bronze membership, one for the silver, and one for the gold. Now, similar to that, in our customer class, whenever we want to create it, we're gonna have to pass in the reference to that same enum class. So our get price method then has a hard-coded value of price being 10, uh, and then we go and have this nested and really hard to maintain if else statement block. Now, the problem with this approach is that whenever we have our clients say, hey, now we want to support, let's say, a platinum level membership. Now we have to go back here and add another else if statement like this. Platinum, and then also add another logic. So for this, let's say it's gonna be 1.5. Sorry, let me change this. 1.6. So right away you can see that, well, if your membership is bronze, you're just gonna return the same price. But as it gets higher and higher in the tiers levels, then we get like a 20% increase, then a 40% increase, and then a 60% increase on that price. So you can imagine how whenever we make a change in our membership enum, we also have to make a change here in the customer. Now, that's really fragile code if we decide to design it like that. So in order to improve it, let's go ahead and start using this state design pattern. So the first thing we're gonna have to do is we're gonna have to um, emulate the behavior of this enum something different, like a interface. So if I go ahead and create the interface membership type, now we're getting a clash because they are named the same. But let's get rid of it. Don't worry about the reds. And then our membership type just gonna have a particular method. Let's say calculate price. This is gonna return an int. So now that we have this interface, we can then create classes that will implement this. So the first one we're gonna do is we're gonna go for each of the particular states that we that the membership type in and had before. So if we go with bronze, then we implement this interface. Gotta generate our calculate price method right away from using the IDE. And then let's say that this one just gets the number, right? So it's just gonna return up a little bit, and then let's create the other one. Silver, the membership type, generate the method, and then this one's gonna have the same logic that we had over here. So let me just copy and paste it, put it over here. Now price doesn't exist, so I'm just gonna hard code it. And that's gonna give us another benefit later on. So just with these two concrete implementations of the membership type interface, we can start refactoring our code. So let's get rid of this. And now notice how the customer construction is also uh, uh, yelling at us. But it's pretty late over here. A little sleepy at the moment. So Now that we have this, now we're gonna have to pass a reference of another object, of a bronze object that matches our criteria of being of the same type of the membership type interface. So now in our get price method, we don't even need the price variable. So now we just need to call type.calculate price and then return that value back to the consumer. So if we run this, here's the result. All right, we got 10. That's what we expected. Now let's try and give him a silver object. Again, there we go. So if we calculate 10 plus a 20%, it's gonna give us 12. So similar in that way, now our code doesn't care which type of membership we pass, either if it's bronze, silver, or whatever other, as long as it's an object that implemented the same interface, it's gonna be able to do it. So let's do another one just to showcase again. So if we go with a gold membership, that membership, then implement the method. Now let's do the same similar calculation. Now this one is gonna be 40%, right? Then better to an int. Now notice how if we change this to gold, run this again, now we should be getting 14. There we go. Now this is the beauty of the state pattern. Like in order to change how we calculate the price over here, we just had to create another object. So this pattern allows us to follow the open close principle that comes from the solid principle, which in particular is going to be the O specifically. So what this principle says is that we shouldn't have to change our current code in order to change its behavior. We should actually be able to write more code and then switch these objects long as they are implementing the same interface, then there shouldn't be any problem. So in the future, if we notice that we no longer need this, then we can use the same IDE and then delete them. But uh, as we have done right now, by applying the state pattern, we were able to extend the possibility. So you can imagine this being in an application. Let's say um, we want to change the, let's say, the file extension of a file. Let's say we're like let's say implementing a like an image converter software. So in this case, you will have different extensions like JPG, PNG, and GIF. So each of these file extensions or types can then be mimicked in the similar way so that you can modify just like creating modify your code by just creating another class that will represent each of the particular individuals file types. So this is really powerful, and I find that it's pretty easy to get the hang of it at first. But if you don't worry. It's a little mind blowing the first time you see it. But if you practice it a little bit, you will see that writing the huge block of that we had before, like in the if statements, it may feel that you will go faster, but at the end of the day, it's not really that much. If when you go back a few months later, it's really hard to read and wrap your head around it. But instead, if you go ahead and when you start noticing these patterns, then you can go ahead and like refactor in this way and make your code a lot cleaner and and easier to change in the future. So that's it for it now. Uh, Thanks for watching, and let me know in the comments if you have any questions.